Now, you really do need to, in the exam or real life situation, you really would use, I mean, you would tend to use a bit of binomial distribution when it comes to things like quality control, comes to things like, it's applicable in terms of biology. If you do some research, you will use quite a bit of it in terms of quality assurance if you're in that sort of field. So it is actually quite useful. All right, let's think about solving some problems, practical problems, and you need your class pad for sure today. All right, so this is a summary. These are the formulas you'll get from your formula sheet. So you do know what Bernoulli, you can work out the mean. The formula of the mean for Bernoulli is given, for binomial is given, and discrete random variable is given. And you've got the variance as well. So standard deviation is just square root of variance. It's not given to you, but remember that standard deviation is square root of variance. So they could use mu and sigma square. All right, just remember what mu is. That is the mean. That sigma square is the variance. Bernoulli, the mean is a sample proportion, and the binomial distribution. You must remember how to use your Pascal triangle or your Bernoulli, or your binomial, whatever. All right. So let's start off with the first question. The probability that Neo wears his favorite gray jacket each day is 0.84. I highlighted that. Determine the probability that in a typical 7-day week, he wears the gray jacket every day, he wears the gray jacket on exactly 2 days, he wears the gray jacket on Wednesday and Friday only, he wears the gray jacket on at least 1 day, more than 5 days, and so on and so forth. All right? So, you know that he's either wearing the gray jacket or not gray jacket, correct? So it's Bernoulli. And then, think about it, binomial, because if it is a 7-day week, so you would think about maybe, like for example, part 3, you've got 2 days that he's wearing it. Alright? Or part 2, actually, he's wearing the gray jacket on exactly 2 days. Alright? Part 3 is slightly different from part 2. I'll explain it in a few minutes. Then you've got to know, determine the expected number of days that Neo will be wearing his gray jacket in a 7-day week, so on and so forth. Alright? Let's start off with example question 1. So in this situation, you know that it is going to be a binomial distribution. So therefore, if we let x as Neo wears the jacket, all right, the number of days Neo's wear jacket, so therefore you know that x is binomial distribution with the parameters of 7 and 0.84. So success is when he wears his jacket 0.84. Other days he doesn't wear the jacket, which is 0.16, right? Because both adds up to be 1. And we're talking about a 7-day week. Alright, so first one, he wears the jacket every day. So its probability of x equals to 7. You can use your calculator or you can use a formula like this to work it out, which is 7 choose 7, and then 0.84 to the power of 7 and 0.16 to the power of 0. In this case, you know that 7 choose 7 is 1, and it's just only 0.84 to the power of 7, correct? Yeah?
Go in graph mode.
Or you can use your calculator. I'll show you in a few minutes. He wears the gray jacket exactly 2 days. Alright? So now, I just wrote down probability of x equals to 2 is 0.016. You could use your class pad. So you know that x is binomially distributed 7, 0.84. Alright? If you use your class pad, you need to go to main and go to interactive. Alright? Distribution, discrete, binomial PDF, X is 2, num trial is 7 days, and probability of success is 0.84. Alright? Click up. Hang on, what am I doing? Yep. What have I done? Let me clear everything first. I should clear everything. So interactive, distribution, discrete, binomial PDF, X is 2, num trial is 7, that is 0.84. Okay. Yep, 0.015. Alright, so this is how you actually do it. Okay, the answer 0.016, 4 decimal places. Always keep your answer to 4 decimal places for probability. So that if you need to give you the percentages, it's 2 decimal places. Alright. Now, okay, the part C, determine the probability that, part A, number 3, he wears the grey jacket on Wednesday and Friday. Now, this one, order is important. Alright, there's only 2 days that he will wear the jacket, exactly 2 days, which is, not exactly 2 days, it's only Wednesday and Friday. Alright, you're not choosing that any other days anymore. Alright, so the 2 days that he's wearing, which is Wednesday and Friday, it will be 0.84 times 0.84. And then the rest is 0.16 to the power of 5. So the difference in part 3 is that you don't use this anymore because the order is important. You know that Wednesday and Friday he's wearing the jacket, not all the other days. So it's just only 0.84 square times 0.16. 0.84 square times 0.16. So you can see that this is part 3 is exact. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So he is wearing the jacket these 2 days, Wednesday and Friday. So therefore it's 0.84 times 0.84. The rest is 0.16. Yeah? So this question like this, the days are specific, so you need to know that this is how you do it. You're not choosing days anymore. A4.
At least 1 day.
He wears the jacket on at least 1 day. So,
yeah. So the only one that doesn't fit that is 0.
part 4. Oh, sorry, I skipped part 4. So at least 1 day. So you need to know that probability of X is greater than equals to 1. So if probability of X is equal than or greater to 1, alright? I skipped the part 5 straight away, I missed that question. So probability of X is greater, equals greater than or equals to 1 is actually 1 minus probability of X equals to 0. Correct?
Right.
Yeah? So if you do that, you can work out the probability of X minus 0 using your class pad, and the answer will give you whatever it is. Probability of X greater than 1. So you could do that. Probability of X greater than 1 is probability of 1 minus probability of X equals to 0. Alright? So, for the next one, probability of
5. What do you mean?
him wearing the jacket on at least
You did it wrong. I think.
not more than 5. Hang on, what have I done here?
Yeah, I think.
I have no idea what I did, but I've done, I don't know why I've got greater than 4. Alright, that's my fault. So if it is greater than 4, means it's between 4 days and 7 days because it's 1 week. So you have to include 4 and 7. Alright? So assume that I've done it correctly. Greater than 4, greater than or equals to 4. I could use a calculator. Let me show you. So this time, you've got to use interactive. I didn't read the question properly, I think. Discrete. And go to binomial CDF. Because you want it to be between 4 and 7. So the lower is 4 and the upper is 7. The number of days is 7, or number of trials is 7, and the possibility of success is 0.84. And that's the answer, 0.98447. Between 4 and 7 days. Alright, part 5, it is no more than 5 days, is probability of x. No more than 5 days is probability of x less than or equals to 4. Alright? No more than, no more than 5 days is less than or equals to 5. My fault, not less than or equals to 4. No more than 5 days, include 5 as well. So it's x less than or equals to 5. Alright? Which means it's between 0 and 5.
For 4, for A4, isn't it from 0 to 5?
Yeah.
No, which one?
He wears no more than 5.
It's not more than 5 days, include 5.
Yeah.
Yeah.
Include 5.
0, 0,
0, 0, 5. Yeah.
Not 5 to 7.
No, 4 is incorrect. I'm not talking about 5 now. It's not more than 5.
Yeah, he got the 5 correct.
Yeah.
I've got the 5 correct, I've got the 4 incorrect.
4 is wrong.
Yeah, the 4 is incorrect. I didn't read the question properly. So, part 6 is wear the grey jacket every day given that he wore it on at least 5 days. So you've got to think about it as this. So given that he's wore it for more than 5 days, alright? And the probability of him wearing the jacket every day is probability of x equals to 7, which is that 0.2951, and then between 5 and 7 days. So he wore more than 5 days. So you need to think about
Kinematics.
him wearing the jacket.
Oh shit.
X equals to 7. That is the numerator, and given that the probability of him wearing the jacket greater than 5 days. So it's probability of x equals to 7 divided by probability of between 5 and 7.
How do you do that?
Again, use your calculator. So 0 points. I would show you. This is what I'm going to show you. All right. You can use your calculator. Let me between 5 and 7. All right. So use your calculator. What I would do is I will go to keyboard and put in your whatever you call it, your fraction. So the top bit is I can go to interactive.
This is what you have to derive.
Distribution, discrete. So there's a PDF because you want it 7 days. Probability 7, and this is 0.84.
There are actually some things about that.
When you click OK, it says invalid syntax. It's because you have not put in your denominator yet.
The last thing.
Then you put in your denominator, which is interactive.
Last bit. Yeah, that makes
Distribution, discrete.
Otherwise
This
they
time
wouldn't
is
have made it.
CDF.
They wouldn't
Between
have
5
said
days
that.
and 7 days.
Yeah.
And then the number of trials is 7. And the possibility of success is 0.84.
But it's not hard.
All right.
Actually,
Click OK.
last question's very
Now,
hard.
see. So you
Just have to
straight
divide.
away, you put in.
Sort of. Yeah. Sort of.
Hey, no games, please. So straight away you can use your class pad. Where's your class pad?
I was listening.
It's no point listening. You have got to use your class pad. So you can use your class pad. Use your fraction. Put this in. It will say invalid syntax because you haven't put that in yet. And then you input that. You will get your answer. Try that, please. Use your class pad. Do that.
Same answer as him.
It's actually a lot of class pad work, this one. You must know how to use it well. Alright? You must know how to use it well. So it will give you invalid syntax because when you put in your numerator, you haven't put in your denominator yet. Alright? Or you can do it individually.
You can use the actions.
Individually and use one number, divide by the other number. Alright, that's fine.
So you can use action to just give you your action, distribution, discrete.
Yeah, but the thing is, if you use action discrete, it doesn't tell you what you have to put in. You use interaction discrete, PDF, it will tell you what to put in. All right. So I would use, in this situation, I would use interactive rather than action. Action doesn't tell you what you need to put in. All right, especially in the exam. I would just use, whatever you call it, interactive rather than action. All right, so let's go on to the part B. Determine the expected number of days, which is EX, expected number of days, and is N times P. So you need to say that it's 6 days. It's not 5.88 days. So the expected number of days, Neo will wear the jacket is 6 days. Determine the probability that the number of days that he wears the gray jacket is within 1 standard deviation. Alright, so now it says that it's within 1 standard deviation. What was the question?
Of the mean.
Of the mean. So you need to think about, you've got the expected value. Alright? You need to find the standard deviation, which is square root of NPQ, or n times p times 1 minus p. And you got to think about, take away 1 standard deviation and plus 1 standard deviation. Alright? We'll talk about standard deviation a bit more when we come to normal distribution. Alright?
Yeah.
Plus or minus.
Yep, yep.
So you need to be able to interpret the question knowing what is 1 standard deviation from the mean. So work out your standard deviation or sigma, which is square root of n times p times q. Once you have done that, all you need to do is add that, find the standard deviation, mu, which is the expected value, take away the standard deviation, expected value plus the standard deviation. Now, there's not 4.91 days or 6.85 days. So you've got to think about 5 and 6 days.
7 days. 6.8 runs up to 7.
Let me have a look at the question. Determine the probability that you will work within 1 standard. It's within 1 standard deviation.
That's right.
So it's 5 and 6 because it's less than 7. 1 standard deviation is less than 7.
Yeah, because if you include 4, you're including more than
You
1.
cannot include 4. You are including more than 1 standard deviation.
Yeah.
And then 6.85 is less than 7, so you cannot include 7.
Yeah.
Alright,
So
it has to be between 5 and 6.
Can't be outside.
You got to think about what the standard deviation is. Alright, part D. Now, this time, I'm going to let Y as Neo wearing the jacket 7 days in succession. Alright? So if Neo wears the jacket 7 days in succession, and this you are looking at 11 weeks. So the probability of Neo wearing the jacket 7 days per week is 0.2951 from there already. Stop playing games, please. Alright? Grab your class pad out and work on your class pad. So you need to know how you could switch from here, this probability to this probability. You are no longer using 0.84. Yeah?
Yep.
You're no longer using 0.84 because you are looking at the probability Neo wears the jacket 7 days a week, and the trial is now 11 weeks. See the change in question? See how the question has changed? Alright, if you're not listening, you're not supposed to be using a laptop and doing something else. This is one of the most important lessons that you need to know. Why do I bother preparing? Close. not preparing lessons for no reason. I'm not doing questions like this for no reason. Think about what you're doing now, which is 0.84, now 0.2951. Because you are now thinking about the probability of him wearing the jacket 7 days in succession. You're not thinking about him, the possibility of him wearing the jacket every day. Alright, that is what you need to think about. So you can see the changes in question, why the first bit and that bit is totally different. Alright, then we'll look at part D. So once you've got that, you need to rewrite your binomial distribution. So therefore, we can put in y equals 7 is that. Use your calculator. The next one requires Neo to wear the jacket 5 weeks out of 9 weeks. Alright? Then he wears the jacket in week 10. So think about this situation. Alright, part E, read it carefully. Determine the probability that Neo wears his grey jacket every day in a week for the 6th time in the 10 weeks. So if you've got 10 weeks, again the subtlety of the question. 1, 2, 3, up to 9 weeks. Alright? And then the 10 weeks, he must wear the jacket 7 days in a row, and this is the 6th time. Alright? So out of week 1 to week 9, you need to wear 5 weeks. Right? 5 weeks out of 9 weeks, but week 10 is the 6th time that he's wearing it. So the probability of that happening is 0. Whatever it is, 2951. Here, you need to rewrite your Bernoulli distribution. Is y is now, instead of 11 weeks, this is 9. Alright? So now this is 9, and you need to choose 5 weeks out of 9 weeks. Yes, see the question? How it is answered? You need to think about how you're going to link the first bit to the second bit. This time it's going to be slightly different again. The last bit, you need to think about the probability of success. So the probability of success is now 0.2951. And so the first bit is that y equals to 5, that bit, this bit, you use that. Use your calculator, and then the probability in week 10, 0.2951. So you've got 0.0205.
Don't you have to times it by 1 minus p because you still have the 11th week?
No.
Oh, no, there's 2 cases, yeah. Okay,
2 cases. Yeah, 2 cases only.
Yeah.
So you've got week 1 to 9, you've got 5 weeks. Week 10
week
is
10,
you have to.
You could
week 10, you must wear the jacket.
You could not wear it.
Alright, week 10, you've got to think about week 10. He's wearing the jacket 7 days in a row, which is 0.2951. So the other 9 weeks, you've got 5 weeks of 5 weeks out of 9 weeks that you're wearing the jacket. This is the 6th time.
So week 11 doesn't matter.
Sorry?
The 11th week doesn't matter.
Yeah.
No, it doesn't. 11
That's why
week
you
doesn't
don't
matter.
times by anything else.
Because it doesn't matter if he wears something or if he doesn't.
Sorry?
Because that's the probability of wearing it 5 times in 9 weeks. Then don't you also have to times by the probability
No.
of getting it in week 10?
Okay. 0.2951 is the probability that him wearing the jacket 7 days in a row.
Yeah.
From the first week. Alright? So when we look at this situation here, so this is the number of times you wear the jacket in a week. Alright? So first time when we look at that 0.2951 is the probability of him wearing 7 days in a row in a week. So we are talking the first bit, we're talking about just a week. Alright? Now, after that bit, we are actually talking about this bit now. We're talking about he wears a jacket 7 days straight. Alright? So it's a different situation. This is talking about a week, the days of the week. and now this is talking about the whole week. Yeah. So it's a different situation. So the week, all right. This one, the first bit, you're talking about looking at the 7 days in a week. Number of days is where he wears a jacket. All right. So that situation is this: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So this situation is you're looking at every day, the first bit. All right. You think about a week first.
So 0.2951 is probably
Sorry?
he wears it 7 times.
Yeah, wears 7 times. So 7 times he wears it. The possibility in any 1 week he wears a jacket 7 times 0.72951. And then we're going to look at week now. So let's say this is week 1, week 2, week 3, week 4, week 5, week 6, and so on and so forth. All right. So the probability on this week, week 1, he wears a jacket 7 times a week is 0.2951 from the first part of the question. Yeah. So we're thinking about week now. So these are the subtlety of the questions that you've got to think about. Not the easiest question, but this is how you've got to really think about the nuances of the question. All right. All right. Example 2. I'll give you some time to read example 2. Again, it's not obvious. Now, you've got to read the question very carefully. It says that 5.5% of the batteries produced by a certain machine are defective. All right? So the probability of success is now defective batteries. Right? The probability of success is defective batteries. These batteries are packed and sold in packs of 20 batteries each. This is a quality assurance problem. So a pack of 20 AAA batteries is randomly selected from those produced by this machine. Part A, find the probability that the first 5 batteries tested for this package are not defective and the 6th is. Alright, now, so part A is not binomial because you were specifically told that battery 1, B1, B2, B3, B4, B5, they are all okay. Alright? Whereas B6 would be the defective one. That is the situation. You know exactly 1, 2, 3, 4, 5, not defective. The 6th one is. It's no longer binomial. You are not saying that any one of the battery is defective. All right. Read the question carefully. This situation is different from if there's exactly 1 battery that's defective, because we don't know the position of that. This one you know. All right. So let's have a look at that. So the order is important, therefore the probability is 0.945. That's not defective. So if the probability of success or defective is 0.055, I think. Yeah, it's 0.055. Therefore the probability of non-defective is 1 minus 0.055, which is 0.945. Yeah. So you've got to think about it this way. No longer random. That's fixed. Part B. Find the probability that the pack has exactly 3 defective batteries. So that's no order in that. You can use, if I let X be the number of defective batteries. So for the 20 packs, so out of 20 packs, this is what we are looking at. All right. X is the binomial distribution, 20 and 0.055. Yeah. So from there, you can use your class pad, work out probability of X exactly 3. X equals 3 is 0.0725.
Yeah.
Got it? Happy with that? So the next bit, the next one, it says find the probability that the pack has no more than 2 defective batteries. So at most 2. At most 2. No more than 2 defective batteries. You can have 0 defective, 1 defective, or 2 defective. Use CDF. So if you use a CDF, the lower bound is 0, upper bound is 2, and num trial is 20, and the probability of success is 0.055. Alright?
What is that?
Part D. Find the probability that this pack has at least 1 defective battery. So at least 1 defective battery, it has to be greater than 1. So therefore it's 1 minus probability of X equals to 0. Now generally what I'll do is, I'll work that out. I can work out as 0.6774. Part E. Find the probability that a pack has no more than 2 defective batteries if it is known that there is at least 1 defective battery in the pack. So you know that it's no more, it's between 1 and 2, and then X has to be greater than 1. You cannot use 0 because you know that there is at least 1 defective battery. Alright? You can see that the probability here is at least 1 battery because you're given that the condition is such that you have at least 1 defective battery. Again, read the question. You cannot include 0 because there is no nothing said about the pack. Has no the pack has now the question states that it has at least one defective battery. So you need to be able to interpret those questions. Now,
Isn't it from 0 to 2 given that it's X?
No, I already
no, because the question says that
So-
it is known that there's at least 1 defective battery.
Intersection.
So there's no 0. Read the question carefully. The question says that find the probability that the pack has no more than 2 defective batteries if it is known that there is 1 defective battery. So you cannot include 0.
But yeah, I get for the given part, but for the first
12.
shouldn't it be
No.
Mr.
In
Guess and check,
the
bro.
sample that you've already got, you know there's 1 defective battery.
I can't
Yeah,
focus
it is
right now. Yeah, I
So
know.
the next
Like,
bit,
guess and check, bro. never
management
go wrong
is
with guess and
concerned
check.
that the probability that a pack of 20 batteries has at
For this
least
one.
1 defective battery
Guess and
is
check.
rather high. Find the maximum number of batteries that should be packaged in a pack so that the probability
12.
of obtaining
12.
at least 1 defective battery is no more than
Which is
50%.
0.49.
Now this time you need to find n. Alright?
4927.
We are no longer looking at 20. We know that x is the number of defective battery. So what I want is now to find n so that the probability of x greater than equals
that's
to
what you
1
guess
is
and check.
50%. It's less than 50%. Alright? So you need to think about how you go from the question into this statement. Alright? So the question, you need to be able to interpret the question. The question said find the maximum number of batteries that could be packaged in a pack so that the probability of obtaining at least 1 defective battery at least one defective battery greater than 1 is no more than 50%. Alright? We don't know the number of batteries, but we know the probability of defective is 0.055.
So,
Yeah? So that's the situation. Now, what do you do?
guess and check.
Okay. No, you cannot use guess and check, please. No.
It's perfectly
Okay?
reasonable.
Probability of x equals to 0 has to be greater than
I got it on my
0.05.
first try as well.
So you can't use solve function to do this. Alright? Because you know it's n peak 0, 0.55 to the power of 0 is 1. So it's 0.945 to the power of n is greater than or equals to 0.05. And therefore, n is less than 12.253.
So I got it right.
Sorry?
Guess and check.
No guess and check. You can do a table if you want to.
Combination.
Now, my recommendation is when it is x equals to 0. Alright, if you've got this sort of situation, my recommendation is you do that and use your solve function.
Yep.
Alright?
Not guess and check.
Not guess and check. Guess and check, you have to use the table, you got to generate the table.
Not even.
Alright, I wouldn't recommend generating the table in this situation because it's I will show you the situation that I'll ask you to generate the table. This is, in my opinion, better to use ClassPad. ClassPad, once you input everything in, it will actually give you the correct sign as well. Less than or equals to 12.5, so you need to pack 12.
Right, so that times.
Alright?
Wait, so is that times 0.05 or what's the last part?
Greater than or equal to 0.5. That's 50%. Alright? Now, example 3. Amy plays basketball and practices shooting from the 3-point line. He finds during practice her probability of making a 3-pointer is 0.2. Find the smallest number of shots Amy must take so that the probability she makes at least 2 3-pointers is at least 0.72. Alright? So there are 2 at least there. So you know that she must make at least 2 3-pointers greater than or equals to 2. And the probability is at least must be greater than or equals to 0.72. Alright? So those are the things that I highlight. The probability of making a 3-pointer is 0.2. Alright? So you can write x be the number of 3-pointers. And therefore, what we have is binomial, either 3-pointers in or not in. We don't know the n. We are looking for n. We know that the probability of success is 0.2. So always write that down. Always write your distribution down. X,
It's not 5, it's 0.5.
define x and define this. And write that statement, at least 2 3-pointers. So x is greater than or equals 2. And the probability is at least 0.72. So it's greater than or equal to 0.72. Alright. So use the ClassPad, use graph and table function to plot x equals to 11, to plot. So x equals to, so you know, or use graph table. It's either way. Alright, now I'm going to write it out on the board. So x greater than equals to 2, you know is
Yeah. It can't be 30.
probability of x equals to 0 plus probability of x equals to, hang on. So, probability of x equals to 0 plus probability of x equals to 1. Alright? See that?
Yeah.
If you are using the ClassPad, use graph and table to plot. I'll show you what to do. Now, here, I'm going to look at this first. Look at probability of x greater than or equals to 2. It's 1 minus probability of x equals to 0 plus probability of x Yeah? Agree? So I now have got 1 minus probability of x equals to 0 is n C0. Correct? Yeah? And then 0.2 to the power of 0 and 0.8 to the power of n. That's probability of x equals to 0. Right? So probability plus probability of x equals to 1, 0.2 to the power of 1, and 0.8 to the power of n minus 1. Agree? Everyone agree? So, therefore, that equals to 1 minus 0.8 to the power of n. Yeah? Plus, n choose 1 is n. Times 0.2 to the power of 1 and times 0.8 to the power of n minus 1. Alright? So therefore we know that 0.8 to the power of n plus 0.2n, 0.8 to the power of n minus 1 equals to 1 take away 0.72. Greater than or equals to 1 take away 0.72. Which is 0.28. Do you see that? Do you agree with
I
me?
have no idea what he's doing.
So you go through step by step. So x greater than or equals to 2 is 1 take away x equals to 0 plus 1 take away x equals to 1. Alright? And then rewrite that in this sort of situation and choose 0 and choose 1. Yeah? Now, ClassPad cannot solve this. ClassPad you cannot use ClassPad function to solve this. You can plot y equals to 0.8n plus 0.2n, 0.81, n minus 1, and y equals to 0.28 and solve it. Alright? Solve for that point. And you can see that it's x equals to 12. Or, if you use graph and table, let's go to graph and table. So what I want to do to show you is, I want to get a table of binomial CDF. You need to get a binomial CDF. So you know that this is 2 because the minimum is 2. Let's get my ClassPad simulator out. Alright. So what I want to is go to menu. Go to graph and table. I'm going to edit and clear everything. Alright? So I know I'm going to go tap on that, go to keyboard, go to go to B and go for binomial CDF.
Yeah, do with calculation.
Input that.
Also,
So
probably
now
if you're passing.
you know that is the you need at least 2. So the lower bound is 2. Alright? You don't know what n is.
Sorry?
N is what we are looking for. So therefore you put in x. Because it's the upper bound is x.
Yeah.
Right?
Basically.
And
Like,
then of course
There's
the
two ways
n,
you can do
the
it. You can find out the
num is
expected
x as
value
well.
of his mark.
Yeah?
Or you could just do.
And then the
It's not binomial.
success is
No, it is
0.
Three questions.
What's the
30
success?
questions.
Success is
You get 3
0.2.
answers, but that means
0.2.
there's one
Alright?
out of 3 chances.
So
of
once you've
something
got that,
Yeah.
you need to tap on the box, execute, and then go to table. Go to table. It will generate a table. Of course, there will be 1 as error because you're not getting anything less than 1. You want 2 was the minimum. Right? So you keep scrolling
It's
down
still on the-
until
three.
you can
Yeah.
see that x is 0.77251. When x is 12, that is 0.7251. That's the probability. Alright? You can work backwards that way.
Why
Work backwards
do
that
you
way.
solve it with 0.28?
Sorry?
Why do you solve it with 0.2?
Sorry?
Sorry?
Like you're looking for 0.72, but it's 0.2.
1 minus 0.7. 1 minus that equals to
So
0.72. Therefore,
that's
that
correct.
is 1 minus
And
0.72, which is 0.28.
we'll find the
Oh, so then you flip the inequality.
Yeah.
Then you would be.
Okay, that equals to
Yeah, I think you could do two. Yeah, I think
this
I would do
bit
that, or you
equals
could
to
just find the
0.72.
probability of him at least getting.
Therefore,
50.
this equals to 1 minus 0.72.
So
Alright?
if you do that,
Yeah.
p
Got it?
is greater than or equal to 15.
Yeah.
That's just equal to p.
Now, so you must
One
be able to
minus
use
p
your class
half.
back. This will be a question that will come up from for exam.
And this
N,
you can
looking
get
for
from
N.
your CDF 0 to 14.
You use CDF function.
Isn't it 15?
Now, if you are not sure, I'm going to show you a slightly different way of doing it.
15, then
If
you
you're
can
unsure
minus
about the
those
numbers,
15s.
everyone, let's quickly focus, please,
No, but he
on the
needs-
whiteboard.
He needs 15.
Yeah,
Now,
but
go to main.
yeah, so if you minus all those 15s,
Clear
you're gonna
everything,
get rid of
please.
some of the probability. that
Now
you
go
can-
to main. If you're unsure what to put in, you know CDF, but you don't know what the
So,
things are.
the
You
problem
go to
is
interactive. Go to distribution, discrete. Go to binomial CDF.
Less than 4.
The lower is 2, upper we don't know is x, and the num trial is x. Alright? And then the possibility of success is 0.2. Click on that.
True.
Alright? It will come up with this. That's fine. What you need to do is copy this. Edit, copy, and go to your graph and table. Go to your graph and table and paste it there.
Then how do you do that?
Paste it there. And then
Binomial CDF
click on the table,
0
it
to
will work it out
15
for you.
and p.
Alright? Now, if you're not sure, use your main interactive. You will not be able to calculate it, but at least you know what you need to put in. Alright? And then copy and paste it in there. If you're not sure what the things are. Alright? Interactive will tell you what you need to put in. What is so that you don't have to remember your what the x's are.
0.
0.
Sir, could I go to the bathroom?
I'm going to finish. What I'm going to do is, I don't think I have time to do 4 and 5. I'm going to leave 4 and 5 until Monday.
Yeah.
So you can try 4 and 5. 4 is a very interesting one because
57.
4, you need to think about how to answer the
No.
question. 4 is interpreting the question and answer the
Also,
question.
You're going to do 1 minus that.